Here are the solutions to this week's problem set. It'll probably take me at least 2 videos to get through the problem set, but we'll see. So the first was practicing evaluating logs. So when you want to evaluate a log, you want to figure out what it's equal to. So write it equals some unknown x, and then translate it into exponents and solve using common sense. So 3 to what power equals 81? And if you just think about that for a second, 3 times 3 is 9, times 3 is 27. You would need 4 factors of 3 to get up to 81. For the next one, we're going to do the same thing. We'd like to know what this is equal to. So that tells us that 2 to some power is 1 over 64. Now, if it was just 64, 2 times 2 is 4, 8, 16, 32. We would need 6 factors of 2 to get to 64. And to make it into the denominator, the exponent would be negative. Next was to practice identifying the domain of a log function. So that remember, when you take the log of an expression, this expression must be greater than 0. So x plus 2 has to be greater than 0. In other words, x has to be greater than negative 2. So that would be the domain of that function. Write this expression as a single logarithm. So we want to condense this. So let's start here. We know that adding the logs is the same as multiplying, so we can condense those into log to the base 4 of 3x. Now we know that subtracting is the same as dividing, but before we do that, let's take a look at this piece right here. This piece right here is 2 log to the base 4 of y. We know that a number in front is the same as a power, so we could rewrite that as log to the base 4 of y squared. And because we're subtracting, we know that subtracting 2 logs is the same as dividing. So we would have log to the base 4 of 3x divided by, and then we would have here y squared. If you wanted to check that you had done that correctly, then just take this expression, your answer, and expand it. If you tried to expand that, the first thing you would say is, oh, that's the same as log to the base 4 of 3x minus log to the base 4 of y squared. This we know, since we're multiplying, we could add the logs. And this right here has a power, so we could bring that down in front. And you can see that as we check that we got our original problem back. So we know that we condensed it correctly. Probably the most useful section after you get into like what are logs and how do you work with them is how to use them to solve exponential equations and logarithmic equations. So let's take a look at part number 4. Whenever you want to solve an exponential function, the first thing you need to do is get the base by itself. So we have e to the 6x is equal to 13 divided by 2, and 13 divided by 2 is simply 6.5. Then you can take the log of each side. I like to use a natural log. That allows you to bring down the power. So we have 6x times the natural log of e is equal to the natural log of 6.5. And remember, what are we trying to do? We're trying to get x by itself. So first of all, we remember that natural log of e is equal to 1. So to get x by itself, we simply have to divide both sides of this equation by 6. And so we just take a scientific calculator and find the natural log of 6.5 and take that answer and divide it by 6. And we get our x value, a solution for x of 0.3120. I said to round it off to 3 decimal places, so let me follow my own advice. If we round that off to 3 decimal places, it would be 0.312. Try another. Here, the bases are already by themselves, so we'll take the log of each side. So we have the natural log of 3 to the 2x plus 1 is equal to the natural log of 7 to the x minus 2. The reason we take the log of each side is so that we can bring down the powers. So we have 2x plus 1 times the natural log of 3 is equal to x minus 2 times the natural log of 7. And we just have to begin to get x by itself. If you wanted to right now, you could change each of these logs into a decimal, distribute, and then just keep solving for x. I usually like to get my logs on one side just so I don't have to carry around too many decimals all over the place. So I'm going to start by dividing both sides by natural log of 3. That isn't the only thing you could have done at that point. So if you chose to do something else, it's not a big deal. And now I'm going to change this into a decimal. So natural log of 7 divided by the natural log of 3 gives us 1.771. So this is equal to 1.771 times x minus 2. And then it's just a matter of going ahead and solving. So we're going to distribute 2 times 1.771 is equal to 3.542. We're going to subtract 1.771x from both sides. That tells us that 0.229x plus 1 is equal to negative 3.542. We'll subtract 1 from each side. So from here on out, it's just really algebra, often involving a lot of decimals. And then the finishing touch is to divide both sides by 0.229. Divide by 0.229. And so for that problem, we get an answer of negative 4.542 divided by 0.229 gives us an answer of x equal to negative 19.834. Okay, I think we'll have to do the next part in a second video so that we don't run out of time. So we'll do the log equations in a second video.